intermolecular forces! Intermolecular forces! Intermolecular forces! Intermolecular forces! Intermolecular forces.
Intermolecular.
Intermolecular forces.
Intermolecular forces.
Intermolecular forces.
Man? Man? I know you hear me! Ma'am, do you know what an intermolecular force is?
No.
Well, they're forces of attraction and repulsion that act between molecules or ions to influence the physical property of compounds. You really shouldn't stop for strangers!
Intermolecular forces keep the atoms in a compound stuck to each other.
4 types of intermolecular forces are ionic, dipole, hydrogen bonding, induced dipole forces. Ionic forces, opposites attract each other.
Martini.
Yeah. Like we said, ionic forces are oppositely attract each other. Dipole forces are polar covalent molecules that are sometimes described as dipole. Hydrogen bonding is an attractive force between the hydrogen attached to an electronegative atom of one molecule and an electronegative atom of a different molecule. Induced dipole force is a force between essentially nonpolar molecules and are the weakest of all intermolecular forces.
Hydrogen bonds are stronger. For example, take H2S, NO, CH3NH2, Cl2, and Rn. Which is the strongest? It depends on the bond's polarity and molecular polarity. The most polar is the molecule with the strongest molecular force.
Can you list 3 different types of intermolecular forces?
Sure. Dipole-dipole, ion-induced dipole, dispersion forces.
Polarity to you?
It's when a molecule acts like a magnet because one side has more electrons than the other.
Say it again, what is what?
What is intermolecular forces?
It's my good side or bad side?
It's your good side.
Okay, so what is intermolecular forces?
Yes.
That is when atoms in a compound are stuck together, I think, something like that.
Let's watch a human act of what the molecules are doing. Jenna will be playing the molecule HCl. Allie will be playing the molecule Cl2. You're probably wondering why the 2 molecules are moving at different speeds. This is because one of them has a higher boiling point than the other. Can you guess which one? The boiling point depends on the attraction between molecules. Cl2's boiling point is higher because the dispersion forces are stronger than dipole-dipole reaction. The bond between hydrogen and Cl2 is polar and dipole moment is 1.2. The Cl to Cl bond because of the greater polarizability of the electrons. Since it is easy for Cl2 to form stronger temporary dipoles than HCl, the attraction is greater, so is the boiling point. As both molecules continue to heat up, Cl2 stays constantly faster than HCl. It has almost reached its boiling point, but HCl has a while till it reaches its Cl2 speed. Cl's 2 speed is -34 Celsius, and HCl's is -85 Celsius.
Right now, we are going to compare the vapor pressure of acetone to water. We will take these swabs and wipe acetone and water on the table at the same time. As we watch, one will disappear faster than the other. This is because it is evaporating. Here's acetone, and here's water. Go. Go, acetone, go. And the acetone is gone. Notice how the acetone evaporated faster than the water. This is because Acetone isn't very polar, while water is extremely polar, so its molecules are held together fairly firmly, slowing evaporation. This reaction is caused because acetone boils at 64 Celsius and water boils at 100 Celsius. This means that at every temperature, acetone has a higher vapor pressure than water and thus will evaporate faster than water.
Okay. In this video, you have learned about intermolecular forces and their boiling points, and vapor pressures. Let's see how much you remember.
Forces are stronger than diploid to diploid reaction.
Are you kidding me?
Molecular force.
Out of this freaking tree, guys! Just jump!
Just jump! Stupid intermolecular forces.
Bye, die, Miss Humpton.
Too close.
Too close?
Too close.
All right, let's back up. Let's back up. Wait. All right.
Okay, can we do this?
All right, ready?
This is practice, right?
Practice.
Okay.
Action, go.
Okay. Hydrogen bonds are stronger.
Oh!